So first we're going to look at the system at the level 1. That we've got a closed box, and so we're focusing on the environment. It's really important here. We're looking at other machines that it talks to. We're looking what's in the local LAN. We're identifying external exposure from the device. We're not looking at the web server, though. We're more looking at the browser, and we're not looking at the SSH daemon. We're more looking at the SSH access. And we're not taking into consideration any physical interfaces at this stage. We're just looking at this thing and seeing where the cables come out. So for our IoT demo device, we're going to use the deliberately insecure open WRT-based firmware, because IoT GOAT, this is from OWASP, and it's often used for learning. And in this scenario, we've flashed this firmware onto a Raspberry Pi, so that we've also got some physical interfaces that we can look at. This is deliberately vulnerable, so we've got a lot of output and a lot of juicy things that we can use to start our threat modeling. For the ICS part of this, we've chosen a random RTU installed in an energy substation. So the use of this device is to collect sensor data from other points and to execute control commands to breakers and switches. And it talks to it has a human machine interface, and it talks with the SCADA, and it talks with the IEDs as well. So as I mentioned, level 0 is looking at this closed system. So who talks to it? How are we going to get started? Well, you might even start with making a diagram on a serviette in your lunch break, but eventually you're going to want to put it into a more formal format. And I can recommend using Draw.io for this tool. The graphs that I've done today are all done using that tool, and I find it really easy to use and really simple for threat modeling. And we're going to use one other tool at this stage. One of the partners in the CRACoWi project is Bunkai, SevenShift, and we have the tool called Bunkai, which is a network testing platform. And from this platform, we can get a communication matrix. So an overview of everybody and all the devices that this is talking to. So what does the communication do? We see all the outgoing and the ingoing communications for the device. So we can also see what protocols they're using. We can see in what direction it's happening. For example, maybe something is talking to the device, but it's not talking back. The idea is to get this as comprehensive as possible. But there can be complications with this. For example, if you want to note the firmware update, but there's only one and you can't roll it back to do it again, then you might want to add that manually to the list. So if you use Bunkai to make your comm matrix, you attach your device, you set up your VPN, you start your test, you start your comm matrix test, and then you just move through all the normal functions of using the device, from turning it on, from doing all the different things that you would do with it. And if a live scan is not possible because of the environment or because of the constraints of the device or other reasons, you can also upload a PCAP file, and you can add missing endpoints manually. This communication matrix is available for output as a PDF file, or you can also get it as an Excel file, which you can further extend and edit. And that's exactly what we're going to do today. So if you didn't have Bunkai at your disposal at this stage, you could use some Wireshark scans, some network scans. So looking at the communication matrix for the IoT device, we see this web UI access from the host. We see there's an admin login over SSH. We see that the device is probing for DNS. We can see here a file transfer, time synchronization with NTP, and then a multicast DNS. So this already gives us a view of what's in the environment, what's around, and what's being talked to. And out of this, we can determine a list of system components. Here we have the communication matrix for the ICS device, for our RTU. We can see that it's using other protocols like Modbus. We can see that we have an unencrypted and an encrypted web UI. And this can also show us what devices are in the system. For the IoT device, here we have a list of components, and as I mentioned before, I've used Draw.io to make this diagram of the device in its environment. We can see where we can interact with the web browser, we can interact with the SSH, and I've also added here an attacker PC. Depending on your device and the environment that it's in, it might be appropriate to add more attacker points. For example, you'll see later, you could imitate the SCADA system. If you have using a cloud service, you might want to put an attacker cloud service. Just add as many attacker locations as you need that's appropriate for the device. So the idea of this is to look from the perspective of the intruder here. Here we have the level 0 diagram for the ICS device. This looks on the surface a lot more simple than the IoT device, but that's only at this level that it looks so much simpler. We have our RTU. It's interacting with the HMI and IED, and we've got the SCADA, and we've put here an attacker SCADA. Notice that we're only looking really high level here. We're not looking at any internals of the device. We're only looking on a rather superficial level at what it's talking to. So then the next stage is to look at stride, look at the different points, and try to identify what vulnerabilities come out at this level. So here for spoofing, I've identified that the SSH and web UI are accessible over the local LAN. So the attacker can do their best to try and access this locally. We also have unencrypted HTTP, so messages can be read. We have with repudiation, we don't know at this stage if there's any logging. And information disclosure also affects unencrypted HTTP. Then looking also for ICS, we have spoofing. An attacker pretends to be the SCADA system and sends control commands. Tampering, we could change the sensor data to mislead operators. Repudiation, we'll trace this back to logging again, etc., etc. So we're focusing on the exposed services. We can document these threats into our threat model later. So we're going to move to level 1 now. We're taking a different look at the device. We're looking more at the main components, and we're going to take a look at the trust boundaries and trust zones. So we're looking here at edge services. We're going to use two tools here. We're going to use the Bunkai COM matrix, which we just saw in level 0. And we're also going to use the firmware scan for OneKey. OneKey is another partner in the CRACoWi project. And they have a firmware scan tool. So with the combination of these, we're going to gather a lot more data and go down to the next level and see what we can discover and find out. So we're going to take the COM matrix that we had at level 0, and we're going to extend it and use it as a working document. It will help us identify the trust zones and boundaries. We can filter it and add some extra columns. So if you don't have Bunkai, you might have to do a little bit of manual editing on your COM matrix to get rid of duplicates. Bunkai does this automatically, but we're looking for a single entry for each line of communication in each direction. So, for example, ephemeral noise, random TCP packets can be disregarded, and duplicate flows as well. We want to try and refine it down. So we're just looking at the individual flows. We actually want to keep some of the supporting infrastructure that might look harmless at this stage, things like DNS and NTP, because there are actually attack vectors possible over these protocols. So although they might look important at the first glance, they can be. And of course, the device to cloud traffic is really important. You might want to look if there's a content delivery system, if there's a couple of different IPs that are getting hit there, and maybe summarize that. So here I've got the COM matrix for level 1 for the IoT device, and I've just marked the two lines that I would remove here manually. So we have like a random TCP handshake, and we have a duplicate SSH login. And if we take those lines out, we have a really clear overview of the communication at this level. So the next thing we're going to do is look at the results of the firmware scan from OneKey. This gives us a software bill of materials, which you might anyway have for the device. So what is a bill of materials? It's basically a list of ingredients for the firmware of the software, showing us all the third-party libraries that are used. We have a structured list of all the components with their versions, can be with their dependencies. It can also contain the licenses and the metadata. So we have two different formats that we can get the SBOM here. We have either Cyclone DX, which gives us the option to also use annotations in the SBOM, which is becoming more and more common. So here in this system, we're tracking the CVEs and the issues inside the SBOM. Or we can take the SPDX, which just gives us the packet names and versions, which might be easier if you just want a quick overview. So we can get these SBOMs as either JSON or XML formats, and they can be viewed just using any text editor. So here's an example from what we might get out. Here we can see that it's dropped via SSH. This is our SSH daemon. And we can see here the version of it as well, which is really important. It's not always completely obvious what services relate to which flows. So this might be a point where you want to bring in somebody with more knowledge to help you identify which services relate to which items in the SBOM. Here we have SSH declared in the SBOM, but it's not always so straightforward. So then we can combine this information and add it to our COM matrix. So before we had the relevant port and the protocol being used, now we can add the name of the actual service, and we can identify what the purpose of the service is. So we're taking this one step further here. We can use it to help define our trust zones, right? So we're listing all of the components that we found and all of the services that we've identified here at level 1. And then we can write down who controls them. Are they shared? Are they controlled by the user? And then based on that, we can determine the trust level, whether it's trusted, untrusted, or semi-trusted. And then based on that, we can divide the environment up into different zones. Here we see it's done for the IoT device. So we have the edge zone, which are the services which are directly getting spoken to from outside. They're the most exposed. And then we have the internal zone, which is more protected. It's still available because over the web server, you can access the application logic, but it's not sitting right on the perimeter of the device. And here we see our end user zone and our attacker zone. So we can take this and look at each flow from the COM matrix, and then wherever a flow crosses between one trust zone to another, we want to put a trust boundary in between, because these are the risky transfers of information. These are the points, these trust boundaries is where you would want authentication, where you would want encryption, etc. So we can identify each of these crossings, draw a trust boundary there, and then label our boundaries as well. So I've done this for IoT. You can see we end up with 3 trust boundaries, one between the user zone and the device edge zone, one between the attacker and the device edge zone, and here one internal trust boundary between the device edge and the internal zone. And this is the same concept principle applied for the ICS device. We also see here a division within the device itself and between the device and the different services that it talks to. So we can take this information and extend our COM matrix. We can add the service purpose, which we've learned about, the actual name of the service. We can list if it's encrypted or not, and we can note down where our trust boundary is for this line. So when we have these flows identified with our trust boundaries, and then we can take stride once again and try and apply it at this more detailed level. So as you see with spoofing, we're talking specifically about the services that might be being spoofed, right? That we're actually trying to log into the drop bear SSH service with guests, with stolen credentials, or with a brute force attack. With the tampering, we're looking about manipulating HTTP requests. With repudiation, we're talking about logging in the context of specific services, and here we've got SSH and web. Then, yeah, you can see it's on a different level. We're talking about the actual services, and we want to note all these down. We'll be coming back to them later. We can add them to our ever-growing list of stride threats that we've gathered. So here's just an example of how you can track all this in the COM matrix. It's an Excel sheet, so you can add some extra tabs, note down your trust zones and everything in there, keep your list of stride attacks there, and you don't necessarily need a really complex system or tool. This can be something that you can completely reasonably track in Excel.